Hello everyone. My name is Prince Kumar Singh, and today I'm going to present to you one of my project uh, uh, that is linear regression from scratch. So let's just jump back to the project code. Yeah. So let's go from here. So first we imported few libraries: NumPy, Pandas, Matplotlib, Seaborn, and sklearn matrices. Okay. And here we had a data set which has only two columns. Uh, First one is year experience, and the second one was salary. So we stored those well, like basically we converted those columns into NumPy array, an NumPy array, and afterward we checked if they had a linear relationship, and yeah, they had. And okay, so let's see the main code. So here we had made a class normalizer, okay, which had like basically which will be normalizing all the all the values which is in the column x and the y, okay. And for that, here I am going to use we had used, not we actually, I had used z score. So yeah, so basically uh, yeah, we for what we did. So basically, we know that how the Z score we calculate it. So here I didn't use the NumPy NumPy module. Okay, here I implemented it from the scratch, where I had first we calculated the variance and then the standard deviation that we got from variance, and then in the end of the where we just returned this thing um, Z score. And the second class that we had created, that I had created, is linear like this linear regression scratch. Okay, so where first of all we had declared a constructor where we had this LR learning rate, max iteration that had been declared to 1000, and tolerance that is 10 is to power 6 minus 6. And yeah, initially we had given this we assigned weight, that is coefficient, to 0, and in the b, that is interception, to 0. And we had another method uh, that is fit, so where we will be getting to okay, we will be getting two things. That is first is x, that is the feature, and the y, that is the target. So at first we are checking that if both the lengths if the length of both column are not equal, just return it, like just return value error. Okay. Afterward, what we are doing, we are just again we are declaring like we are declaring the variable and assigning them the values that we had did here, okay. And afterward, what we are doing, we are like we are pass basically we are initializing a loop, okay. And here this loop will run uh, this till we reach 1000, like for now, like the number of iteration will be 1000. But again, we had this thing that is this, yeah. So the thing is, if we okay, so basically if we reach that condition, we will just break the loop. And which is if the absolute of previous error minus error is smaller than the tolerance, we will just break the loop. And yeah, so before that we had predicted the value of y that we had did without using numpy array. And afterward we had calculated the partial differentiation uh, of the lost function. Yeah, and yeah, after that, with the partial differentiation that we had calculated, we are going to put into the descent, and from there, we here we will update the value of gradient descent if like if the value is smaller than the previous descent gradient descent, and there we had a method called predict, where we will be getting one value that is x, which has all the features. And again, here we will be just yeah, what is it? It's the function. It's basically what? It's the cost function. With that, we will be calculating, we will be predicting the value and giving it to the array, like giving to the user, which is in the array format. Okay. And again, here we just initialize, we initialize like the classes, and what else? Yeah, basically where we had normalized the data, then what is fit? So fit is basically where here we had processed the data and then predict. So predict where we had predicted the data, and after predict like after running all these cells, uh, we had like we will be printing the values of intercept and the coefficient. At the same time, we will be predicting the values of predictions. So this is the value which we got. And apart from that, we will be also checking the if we will evaluate our model. So for evaluation, we will be using R2 square and mean square error. And after running this evaluation matrices, we the value which the R2 square value which we get is 95%, and the mean square error that we got is somewhere around once tens, 100,000, 10,000 lakh, 10 lakh. So it's around 3 CR. Yeah, yeah, that's all. Yep.